Okay, in this video we are going to finish the last little bit of our notes for today. This is prepping you for your quiz on Friday. So it says, number 3, at time 0, a baked potato is taken from a pot on the stove and left to cool in a kitchen. The internal temperature is 91 at 0. So the first thing that I notice right there is at 0, my temperature is 91. Now keep in mind that that's in the format time, comma, temperature. Okay? Then it says it's always greater than 27. Okay, so that seems kind of random, but seems important. Then it says the differential equation, blah, 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 where H is measured in degrees Celsius and H of 0 is 91. So part A, we want the equation of a tangent line. We want it at 0. Then it says we're going to use this equation to approximate T of 3. So my goal is going to be to find a point and a slope. My slope is going to be dH dt at 0, 91. And then when I plug that in, I'm plugging into my dH dt here, because we know that that's going to be our slope. So for this one, I would do 91 minus 27. That's going to give me 64. And then if I have a fourth of 64, I'm going to just leave it like that. But you could always change that if you want to. Okay? So from there, I'm going to write the equation of the tangent line. It's going to be y minus 91, negative 64 over 4, and then it's going to be x minus 0. Then it says to use that equation to find the temperature at 3. So I'm going to take 3, plug it in right there. So I'm going to have y minus 91 equals, now this is actually negative 16, so I'm going to just go ahead and do it, but you wouldn't have to do that if you didn't want to. Then here I'm plugging in my 3. Now keep in mind the minus 0 doesn't change anything. So I have y minus 91 equals, it's going to be negative 48 when I multiply that together, then add my 91 across. So 91 minus 48, that's going to give me 43 degrees Celsius. Now keep in mind here that this is an estimation of the temperature, not the exact. Okay, then it says use d squared h dt squared to determine whether we're over or under the actual temperature. So that means that I'm going to rewrite my dH dt like this. I'm going to take my negative fourth in the front, and I'm going to distribute that into the parentheses so that I can take the derivative but not written as a product. So it'd be negative a fourth h, and then negative a fourth times negative 27 is now plus 47 over 4. Now keep in mind that when I take the second derivative here now, the derivative of this is going to be negative a fourth dH dt. Because remember, this is an h, my derivative is with respect to t. And then since this is a constant, regardless of what the number comes out to be, the derivative of that is 0. Now, notice in this one it does not say in terms of h, but if it did say in terms of h, then you would have to rewrite this as negative a fourth, and then take the original crap that I had up here and plug it in. So it'd be negative a fourth h minus 27. Okay? However, it doesn't say that here, but I'm going to still go ahead and write it just to make sure that we remember that, since that's pretty common on the AP test. Okay, then from here, we want to know dH dt squared at our point, which is 0.91. Okay, well then that's going to be negative a fourth multiplied by whatever dH dt is. Well, I found that earlier, and remember it was negative 16 here, or negative a fourth of 64. Okay, but either way, the important thing about that is that since both of these are negative, when I multiply those together, it's going to come out to be positive. And remember that that tells me that h must be concave up. Around 0.91, then tangent line is below actual value. Okay? Now, this next part, part C, is a little bit different. Look what it says. For t greater than 10, an alternate model for the internal temperature of the potato at time t minutes is the function that satisfies the equation, bam. So all of a sudden, we've completely abandoned this other one, and now we have a new equation. Then it says that g is measured in degrees, g of 0 is still 91. Find an expression for g. So instead of them having us solve the original one that they gave us, they're giving us a brand new differential equation to solve. Now, this one is a little bit of a curveball because it is not the same type as all of the other ones in this packet that we've been looking at. So we need to think about how to separate this. I'm going to think of this as -1 multiplied by g minus 27 to the 2/3, so that when I separate, my g stuff is going to have to divide to the bottom, my dt is going to have to move up. So I'm going to have 1 over g minus 27 to the 2/3 dg, and then -1 dt. So my g stuff is moving down, my dt is moving up, that I'm going to integrate on both sides. So on this side, I'm going to end up needing u sub. My u is going to be g minus 27, which means that my du dg is 1. Then I move my dg up, which means that dg is du over 1. Now, I know that some of you guys have been confused about all the different letters. Just think about whatever letter is on this side, that's the letter that's going to be on the bottom because you want them to match. So when I plug in a du over 1, keep in mind that's not really going to actually change anything when I do my integral here. Okay? So I'm going to have the integral of 1 over u to the 2/3, and then du is over 1. Well, I'm not even going to bother to put that. Now, I need to rewrite this because that is an exponent on the bottom. That is not an ln. Okay, if it's not 1 over u exactly, then you need to rewrite it as a power. So think about, I need to add 1 to -2/3. Well, if I'm adding 1 to -2/3, that's going to be u to the 1/3. And then to get rid of to divide by 1/3, I have to multiply by a 3 in the front. Okay, so that's normal power rule. I add 1, which gives me a 1/3, and then to divide by a 1/3, I multiply by 3. Okay, on the other side, actually, let's rewrite up here. So now I have 3 cubic root, because remember, that's what 1/3 is a cubic root. And then my u expression was this, g minus 27. Okay, other side, however, is easy. If it's a -1, the integral of -1 is -1t plus c. Now remember, I want to get all of this stuff together. So my next thing that I'm going to do is multiply by a 1/3. And remember that I need to multiply by a 1/3 on the whole thing. So a 1/3 times 3 is going to cross out. So now I have this, g minus 27. And then on this side, instead of being a -1, now it's -1/3 t. And then a 1/3 times c, well, nobody cares about that. We didn't know what c was anyway. So now I have -1/3 t plus c. From here, I'm going to cube both sides. Okay, so I'm going to have cubed crosses out my cube root. So I have g minus 27 equals -1/3 t plus c, quantity cubed, and then my last step to get rid of the minus 27 is I'm going to add it across to the other side. Now, if you were in my second period class, we solved this a little bit differently. Don't worry, neither one is wrong. They're the exact same thing. Okay, even though they are written a little bit differently. So from here, I would plug in 91 is the answer. When I plug in -1/3, my t is a 0 plus c cubed plus 27. Now keep in mind that a 1/3 times 0 is 0, so that crosses out. So basically I have 91 equals, okay, this is now just a c cubed, and then plus 27. Well, then from there, I'm going to subtract my 27 across. Okay, that's going to cross out. 91 minus 27 is going to give me 64. And if 64 is c cubed, then I'm going to cubic root both sides. and c is going to come out to be 4. Now, keep in mind that since it's a cubic root, you don't have a plus or minus in front. C is just 4. So my final solution comes out to be g equals, I'm going to write it just down here, negative a third t plus 4 quantity cubed plus 27. Now, when I did this in second period, the one thing that I did differently was I had factored this negative a third around the t plus c, and what you'll notice is that when we did it in class, we ended up getting, I think it was a minus 12. Let me double check here. Oh no, it was a plus 12. Okay, so now look at the difference. Okay, so look, you can see what we did in class here. Okay, we had the 1/3 on the outside, but the big difference here is going to be, the big difference here is that we had the negative on the t on the inside, so let me fix that so these look identical. So I had, this stays negative, sorry. So when we got to here, we kept the negative on the inside and the plus c here, but our c came out to be 12. So I want you to just think about, if I plug that c in right here as 12, then I get a third negative t plus 12, and then cube plus 27. Okay, these are the same thing, because if I were to distribute that 1/3, this is still going to come out to be 4. So neither one of those are wrong. Those are both fine. Okay, then for your last part D, it says to find the internal temperature of the potato at 3. Well, then I'm just going to plug in 3. So G of 3 equals, I'm going to use this top version just because I think it looks a little bit easier, but it's negative a third now times 3 plus 4 cubed plus 27. Okay, well, negative a third of 3 is negative 1 plus 4. Negative 1 plus 4 is 3 cubed, plus 27 is 27 plus 27, which comes out to be 54. Okay? Now, also, I want to point out to you that if you were in second period and you had used our equation, okay, which was this, you'd end up getting the exact same answer. Okay, I'm going to show you on the paper that we used in second period. So remember here that our G had come out to be this. It was a third on the outside, negative t plus 12 on the inside, plus 27. Okay, well then I'm going to plug in my 3 here. Okay, negative 3 plus 12 gives me a third of 9. Okay, and then cubed, and then plus 27. But then think about, for my order of operations, I need to do my parentheses first. So a third times 3 is still 3 cubed. And then plus 27, I still end up getting 54 when I find G of 3, even in the other version of the equation that we did. Okay, so hopefully this helps, and good job.